So I was stuck with step function recently, and I worked with step function a long time back. So I wanted to refresh my knowledge on step function. So did some exploration with step function last night and today. And what I explored, I thought I'll share, right? And the use case that I talked to or I took to explore is, let's say I have a chat transcript and then I want to give the chat transcript to an AWS step function. In that step function, the first step is to log the payload, to log the actually the transcript, basically to see if something happens, or if a error happens in the flow. If I have to come back and see what the payload is, this logging the payload will help me to look at the payload. Then the next step is how I can summarize the transcript, and then finally output of that summarization, how I can store the summarization in a DynamoDB or in JSON type of thing, right? Each of them is a Lambda, and I have not coded it end to end because I wanted to just check out some of the capabilities of step function. So each of them, I've done hard coding. So here I am not actually calling a language model, but just hard coding the summarization output and returning it. And the store summarization also, I'm not actually calling the DynamoDB to store it, but I am just taking the input of this as an or output of this step as an input, and trying to see if I can accept that input and display it. It was just to explore the features of step function. I was not exploring the features of Bedrock agent or DynamoDB, right? So for each of them, I wrote a Lambda. So let's look at those Lambda first, and then I'll show you how I did the stitching together, right? So the first one is the log state function, which is nothing but if I it is a simple Python code. I get the event, right, and I log the event, right. I just print the event, right. That is this Lambda. The summarization transcript one is a process transcription, which takes the payload. The transcript is a payload. I just print the transcript, and in the transcript, um, the content of the transcript is so transcript is actually the JSON payload, and within that I have a key, content key, which has the content of the uh, uh, transcript, right? And the summary of the transcript, I'll put it in the summary key, right? And this is the in the JSON, this is the key, and this is the value for that particular part in the JSON payload, right? This is also a very simple Lambda. And then the last one I had is the uh, storing one, right? So that one is the display summary, right? This is also a very simple Lambda function. I take the payload, right, which the payload that comes from here as an event, and then I just print the event, right? This three Lambda, I stitched it together in this step function, step function, right? Where, so let me open this, edit the state machine, and this is the flow, right? First is a log state, then creating the summary, and finally displaying the summary. If I go to the state machine code, Amazon, I think ASL is what it is called, right? So the started is a log state, which is this, right? It's a type, task type. This is the ARN of the Lambda, right? The arguments is where I give the ARN and the function name. This is the handler, the Lambda handler name, right? And the ARN of that Lambda. And the payload is the input, right? So $states.input, that's a inbuilt uh, uh, keyword like within step function, which helps me to get the input and give it to the Lambda. And the output is again like it's a reserved keyword where the states dot result dot payload as a output, right? And then retry is um, if any of these things happen, if the Lambda service exception or AWS Lambda exception, or if there is any client exception, too many request exception, then it will do a exponential back off type of retry, right? And the next um, state is the process transaction. In the process transaction, again, I have the ARN of the process transaction lambda. Here also I take the states dot input, which is the output from the previous one. Here also I have the exponential backoff. Then the next one is the display summary, which is this one, right? It also takes the input, states dot input, which is the output from this one, right? And after that, I end it, right? So now if I run it, so let me execute it from here. I'm just testing it. So it is, so let me take the payload. The payload is, I was testing this process transcription. This is the, let me take the payload from here. Right. So the payload I'm going to give is, this is the one I was still talking about. This is the chat transcript, right? With the key as content. So if I give this as an execution, start execution, it is done now because it is just a simple Lambda function. So now I can, okay, now it is done. So if I look at the log state, right, it got this as an input and this is what it logged. It was the output, right? Since this, whatever payload I get, right, output, I log that output, right? It's the input and the output are the same, is the payload logging. The process transaction is where I take the input. Then if you remember in the Lambda, I take the input and then create this output payload like this. If I go to the function process transaction in the code, I create the uh, payload. I go to the code. So this is where I create the payload. Like transcript contains the content and the summary contains the hard coded thing, right? That is what it is now, transcript and the summary. And finally, the display summary takes this output as an input, right? And finally, it gives me the output. This one I can now store it in DynamoDB or whatever, right? I could have written it in the Lambda itself, right? So where the data, so there is a message and a data. The data contains the payload, right? So that's what I explored with the step function. Um, so this is like step function. I worked long time back, so this was an exploration to see um, what additional features it has. It looked pretty cool to me. It being a state machine, it manages the state. Um, it automatically, if something fails, it allows me to do exponential back off and all without me mm, uh, have to like I didn't have to code anything extra for exponential back off. It is inbuilt within the state machine, right? So that's all I wanted to show as part of step function. I'm going to focus more on step function now that I find it pretty useful. I've been using other type of orchestrations, right? But the step function looks to me something that is worth using and worth exploring. Thank you.